Alright guys, this video we're going to reverse what we did in the previous like 4 or 5 videos. Now we're going to graph lines and circles just like the last videos, but now they're going to be given in rectangular form or a rectangular equation where you have x and y in it, and we're going to replace it with r and theta. Alright, now these ones we already know. Like if I ask you to graph 5, 6, and 7, you should know how to do these within like a minute. Right? These are going to be lines. Let's do that first. That's the easiest part. Then we'll change the x's and y's and replace them with r and thetas. All right, number 5, this is the x equals 3. This is going to give us a vertical line. So we go right to 3 on the x-axis, which is right here, and I just draw a vertical line. For the y equals 4, this is, I go to 4 on the y-axis, 1, 2, 3, 4, and this gives me a horizontal line. All right. Again, I'm really not testing you on this. I already know you guys know how to graph lines, but I'll just start off with this. For 7, if we did this, probably the easiest to get it in slope-intercept form. If you get y by itself, let's see here, you're going to get negative 3 over negative 2. They cancel out. Your slope's going to be 3 over 2. 2 divided by negative 2 is negative 1. Negative 1 is the y-intercept. All right, and when you graph this, good old slope-intercept form, we go to negative 1 on the y-axis. Then we use the slope, so we can go up 1, 2, 3 to the right 2. All right, I'll put a point right there. Then we'll connect it. 1, 2, 3 to the right 2, which is right about here. Connect it, we have our line. All right, that's the easy part. All right, that's Algebra 1 stuff right there. All right, main thing is now I want to take these equations and replace the x's and y's with r's and thetas. All right. All right, let's take a look at 5. Let's zero in on this. All right, x. So if I just have x, what can I replace x with? Well, remember, when we convert, x is the same thing as saying r times the cosine of theta equals 3. Okay. The other thing, I'm kind of looking at my notes now. I forgot to put this down. I'm going to slide over here where it says hint. What you want to do is you basically want to solve for r. For all of these, you want to get r by itself. Kind of like mostly when you graphed in rectangular form, you wanted to get y by itself, unless it was, a special case like number 5. So we want to get r by itself. Should have been one of the first things I put down. All right, so for number 5, if I get that r by itself, I'm going to divide both sides by cosine of theta. Cancels, I divide this by cosine of theta. So you're going to have this, r equals 3 over cosine of theta. Now this should look familiar. It's actually, I think, almost identical to number 3 that we did. When we move cosine up, it's going to give us its reciprocal, which is secant. So it's r equals 3 secant of theta. All right, and number 3 right above us, that was r equals, 4 secant of theta, and we got a vertical line at x equals 4. Well, this is r equals 3 secant of theta, so we get a vertical line at x equals 3. All right, so kind of using that logic for 6, well, instead of having it being secant, it's going to be cosecant. So real quick for this one, the y, we can replace this with r times the sine of theta equals 4. And then to get r by itself, we divide both sides by sine of theta. And then you're going to have this, r equals 4 over sine of theta. When you bring that sine of theta up top, it becomes its reciprocal trig function, which is cosecant. So this polar equation is r equals 4 times cosecant of theta. And that would give us this graph. All right, and then the last one, we have both x's and y's. So that means we're going to have both sines and cosines. All right, so again, the x's I'm going to replace. Let's make this even a little bit bigger here. X I'm going to replace with r cosine of theta. So we're going to have 3 times r cosine of theta minus 2y. So the y we're going to replace with r sine of theta. And this equals 2. Now that we're looking at this, it's like, all right, we need to get r by itself. Since we have two r's, I have an r here and an r here, the key to this, to only getting one r's, is you need to factor out an r. Right? That's the common factor on the left side of this equation. So we're going to factor out an r, and we're going to have r times 3 cosine of theta minus 2 sine of theta equals 2. All right. Then to get r by itself, this whole mess that's inside the parentheses, I'm just going to divide that. All right, because it's r times whatever's in parentheses. So I'm going to divide this by 3 cosine of theta minus 2 sine of theta. This whole mess goes away, so we have r by itself. And then I'm going to divide this side by 3 cosine of theta minus 2 sine of theta. Now you might be thinking at this point that you can bring these up and make them secant and cosecant, but you can't because you're adding or subtracting them. All right, if you were multiplying them, you could. Like if it was 3 cosine of theta times 2 sine of theta, you could move them up and change it to secant, cosecant. But since you're subtracting, you can't. So that mess right there, you're just going to leave it like that. This is going to be 2 over 3 cosine of theta minus 2 sine of theta. All right, so just know if you have x's and y's in both, when you convert it to polar form, you're going to have sines and cosines, and they're going to be in the bottom. Okay, but these are ones where you graph lines.